In this video, we'll do an example of an infinity times zero indeterminate form that I use L'Hopital's rule on. So the example is the limit as x goes to infinity of x squared times, in parentheses, cosine of 1 over x minus 1. Okay, so to get us started, let's try plugging in. And plugging in infinity into the x squared gives me infinity, and then that whole thing will be times the cosine. Cosine of 1 over infinity is going to be cosine of 0. And then minus 1. So we have infinity times, this is 1 minus 1, which is 0. So we have infinity times 0, which is an indeterminate form. An indeterminate form. We've seen this before earlier in the course. I can't just say this is 0 because I'm multiplying by 0, because this 0 isn't actually 0. It's just really, really close to 0. Okay, so I can't just say the product will be 0 necessarily. Okay, so this isn't a form I can use L'Hopital's rule on. What I'm going to try to do is I'm going to try to rewrite my limit. And the general strategy is when we have an infinity times a 0 situation going on, rewrite these limits as fractions. So typically what we'll have to do is, if we don't have a fraction, we'll bring one of our terms to the denominator, and when we do, we'll reciprocal it. All right, so with our limit, we got the limit as x goes to infinity. So we're going to introduce a fraction. So the two things that are being multiplied are the x squared. So either I could bring the x squared to the bottom, or the cosine of 1 over x minus 1, I could bring that whole thing to the bottom. But whatever I bring to the bottom, I'm going to have to reciprocal. So if I bring the x squared to the bottom, I would reciprocal it and get 1 over x squared. Okay, and that would leave me with cosine of 1 over x minus 1 on the top. And typically, I usually want to bring the term to the bottom that's easier to reciprocal. And I would say x squared is a lot easier to reciprocal than the cosine of 1 over x minus 1. I could reciprocal that, it would just look more complicated. That would give me like 1 over cosine of 1 over x minus 1, and that just looks more complicated. So I prefer this first way. Alrighty, so we have this. Now, let's try plugging in. And if we do, we'll get cosine of 0 minus 1 on the top, which is 0. And on the bottom, we'll get 1 over infinity, which is 0. Now, this is a form I can do L'Hopital's on. Okay, so this we like. So we're going to do L'Hopital's rule, which will give us the limit as x goes to infinity. And then I take the derivative of the top. So the derivative of the cosine term, I need chain rule. Derivative of the outside will be negative sign. I keep the inside the same, the 1 over x. And I multiply by the derivative of 1 over x, which is negative 1 over x squared. And the minus 1 will go away because that derivative is a constant. And on the bottom, the derivative of 1 over x squared will be negative 2 over x to the third. Okay, I can simplify this. We get the limit as x goes to infinity. Overall, I have these 3 negatives. I can cancel 2 of them and just be left with 1 negative. So I'll just put the negative in front of the sign term. And then I could cancel this x squared on the bottom with 2 of the x's and the x to the third. Okay, so that'll make the 1 over x squared go away entirely, and on the bottom, I'll still have the 2, and I'll still have 1x. Okay, now let's try plugging in. If I do that, we'll get negative sine of 0 over 2 over infinity, that's 0. So this is 0 over 0. So let's try L'Hopital's one more time. So let's try L'Hopital's one more time. We get the limit as x goes to infinity. For the top, I need the chain rule again. Derivative of negative sine is going to be negative cosine. I keep the inside stuff the same. And then I multiply by the derivative of the inside, which is negative 1 over x squared. And then over the derivative of the bottom, which is negative 2 over x squared. And now I get an even nicer cancellation. We get the limit as x goes to infinity. In fact, let me write it on the bottom line. We get the limit as x goes to infinity. Again, 2 of these negatives cancel, so I'll just keep the negative in front of the cosine. Negative cosine of 1 over x. And then I could cancel these x squareds perfectly, and what will be left over is that 2 on the bottom. All right, and now if I plug in, we'll get negative cosine of 0 over 2, which is just negative 1/2. And that is my answer. So remember again what the key idea was when we had this limit of the form 0 times infinity. It was to rewrite it, bring one of these terms to the denominator, typically whichever is easier to do, and then reciprocal it. And when you do that, you should now hopefully have a limit of the form 0 over 0 or infinity over infinity that I can then do L'Hopital's on.